Hello and welcome back. Alright, so today we're going to finish up our talks about inheritance with three topics. The first topic is multiple inheritance. Multiple inheritance. And the next topic will be abstract classes. And finally, a little bit about this thing called interfaces. Okay, multiple inheritance. This is not to be confused with this structure that we've already looked at. A, B, C, D. While this, technically looks like what could be called multiple inheritance, as there are multiple items being inherited along a single inheritance chain, that's exactly what this is, though. This is single inheritance. D derives from one and only one class C, C derives from one and only one class B, and B derives from one and only one class A. In a multiple inheritance case, let's say we had the classes A and B. Well, in a multiple inheritance, A or C would derive from both A and B. So C would gain the functionality of class A, and it would gain the functionality of class B. And that is what is called multiple inheritance. So multiple inheritance is deriving. Oops. Oh, my pen's being a little funny. Deriving from multiple classes. Okay, that's what multiple inheritance is all about. Okay, now let's go ahead and take a look at abstract classes. Abstract classes is the concept where the class cannot be instantiated. Oops. Can't spell it either. Instantiated. Okay, so what this means is that when when we normally declared a variable, let's call it A, or the class is A, and we type in A as the name, this compiler here, that's what that means, is it can't be instantiated. It means that the compiler is not able to actually create a valid value on the stack for this type. And so this is useful when we want to find contracts, or we want to provide some base implementation for functions, but we don't actually want the user to be able to create an actual instance of this class. And we do this by marking a function as pure virtual. Marking a method as pure virtual. And essentially what that boils down to is assigning a function the value of 0. And I'll show what that actually looks like in code. It's kind of a weird syntax. You don't actually write something on the class like you do with some other languages. So in C++ is how you do it. In other languages, it's a little more nicer. Like in C#, you can just add an abstract keyword to the class definition, and it's really clear. In C++, we use this kind of funny syntax at the end of a function definition. And we'll go over into looking at that. Interfaces. Interfaces are this interesting thing, in that they are talked about a lot, but from a conceptual point of view in software engineering, they don't exist. What interfaces really are, they are a language-specific contract for your code. And basically what they are a workaround for C++'s ability to do multiple inheritance, whereas other languages don't actually allow multiple inheritance. So if we look at C++, it allows you to derive from multiple base classes. All fine and dandy. If we look at languages like C# and Java, they are both single inheritance only. They only allow you to derive from a single class, but they do allow you to not necessarily derive, but be associated with multiple interfaces. So they did that to try to reduce some confusion and to do some other constraints on the language. But essentially, an interface in the software engineering sense is nothing more than an abstract class. The major difference when we start talking about language implementation is that an interface contains absolutely no data. They are method signatures only. So you might ask yourself, why is this actually useful? Well, it's useful because we may want to, like if you wanted to create an iList interface. Okay, let's take a C# example. A list contains a bunch of different functionality, right? It has an insert, let's say, and a delete, just for brevity's sake. Well, we can implement all sorts of lists. So we can create a linked list, we can create an array list, we can create a sorted list, we can create a reverse sorted list. Well, all of those need this insert and delete functionality. They all need this functionality. So we will call this the contract. Well, an interface allows you to always reference in your code by this type. Let's say you have some iList pointer. And an interface allows you to do that so you don't actually have to know at certain levels in your code. Let's say you want to pass the list around to another function to print out some data. Well, the printing of a sorted list versus a linked list versus an array list versus a reverse sorted list, it doesn't matter. You always start at the first element and go to the last element and print it out. So you don't need to actually create 4 different functions that take in a reverse list pointer, a linked list pointer, an array list pointer, a sorted list pointer, because the functionality is the exact same in each one of those lists. And so with that's what this contract or this abstract class or interface is really useful for. You can assign one of those specific types to a lower level type, a less specific type, I guess is one way to say that. A less specific type that still maintains the contract that you need to work with. So if you needed to print, we would need another function maybe called getAt. And then we pass in some index. Right? So you can get it 0, get it 1, get it 2, for example. And each one of those implementing class, the array list, the sorted list, they're all going to have this getAt function. We know that because we've said that it implements the iList interface, or it actually derives from the iList base class. And that base class may be abstract, it may not be, but it doesn't really matter. The point is that you're going to guarantee that you have these method signatures, and that's the entire purpose of the abstract class or interface, is to guarantee that you're going to have a certain set of functions that you can work with. That way you can pass around a lower level type, a less concrete type, and it makes our code that much cleaner and that much easier to use and to actually write. So I hope that made sense. Let's go ahead and jump over to Xcode and let's look how we do multiple inheritance. Okay, so this is just a brand new C++ project in Xcode. Nothing special. We're going to go ahead and define all of our classes in our main CPP file just for simplicity's sake. Okay, so let's create, let's pretend we're going to be creating a game. And our game, there's going to be a mage class. Okay, we'll create a public scope inside mage. And we're also going to have a class called a priest. Okay, so far we've seen nothing special here. I'm going to go ahead and create a new mage. We'll call him, let's give him a name of, I don't know, what's a good name? Bob. And we'll create a priest called Henry. Okay. And pretty much that's all we can do right now because we haven't actually defined any functions. Well, we know that all mages and all priests are going to be of, they're going to need some commonality, right? We're going to need to be able to pass in a pointer to one of those types and still be able to interact with things like its health. Um, so let's go ahead and define a base class for that. So we'll have a class called character. And inside character, we'll create a public section and we'll create a private section. And just for fun, we'll create an int health. So it actually looks like we really need a base class here. All right, so let's go ahead and make mage and priest derived from our character class. Oops. Okay, so up until this point, this is really nothing new. This is what we learned in our single inheritance video. So all is good right now. Let's say we want to create another class. And that class is going to be called the shaman. And now the interesting thing about a shaman is that a shaman will have the ability to cast spells like a mage, and it will also be able to cast spells like a priest. So this is where our multiple inheritance is going to come into play. Well, so what we do is we do public mage, and instead of just being done there, we just do a comma, and we do public priest. And so really, the right-hand side of our colon operator here is just a comma-separated list of the different base classes for our class. And it works exactly the same. We have shaman is being derived from mage, and all of the mage functions should have a maximum visibility of public. Shaman also derives from priest, and all of those functions inside the priest should have a maximum visibility of public in our shaman class. And so we can create a new shaman. We'll call him Frankie. Okay, we can build, and we should probably get some warnings here. Oh, I forgot to close off my character class. And so character, okay. So we build, and we'll say, hey, we have some different issues here. Oh, wait, no, I didn't. Public. Unexpected unqualified ID before public. Oh, my goodness. These are really bad. All of those public keywords should have been class. I was talking about C# and got confused. Okay. We have class character. This is what we should have had. We should have 3 warnings because our variables are not actually used. All is great. Okay. Well, if we think about our functionality that's common to all of our classes, well, let's make sure all of our characters can talk. So let's go ahead and create a talk method. And I'm going to provide, well, we'll just do this for now. I want each of my deriving classes to implement their own talk method. So let's just go ahead and copy that over to mage, and I'm going to provide an inline definition for this method, and we'll say mage's rule. End line. Okay. And if we build at this point, let's see, we'll get 3 magic errors, and those errors is that it can't find the actual linkage of this. So one way we can remedy part of that problem is let's go ahead and make our character class an abstract class, and we'll mark this talk method as virtual. And so, like I said, it's really just as simple as assigning equals to the talk function, to the talk method. It's kind of a weird syntax, but if you think about what it's doing, so I built and popped up some errors, so I'll talk about those in a moment. If you think about what it's really doing, is saying the talk function is pointing to 0. There is no implementation in our virtual table for the character's talk function. And so that's really what it's doing. It's a weird syntax, but it's conceptually exactly what you think should happen. Okay. And so now I want to show you what these two errors down here are. We're going to get the first one is Henry is an abstract type of priest, and we think, well, no, it's not. It doesn't have any pure virtual methods. Well, it actually does because character is a pure virtual method. So what we need to do is we need to define that functionality inside priest. And so priests think they rule, and if we rebuild, we'll still get the same last error with. Oops. We rebuild, we should get the same last error with Frankie. Oh wait, we don't. Why is that? Well, that's because Frankie is a mage, and he's a priest, and that function has been defined. So let's go ahead and call talk on each one of these. Henry, talk, Frankie, talk, and we build. And now we get a different error. You notice that we didn't actually get the error. I'm going to go ahead and comment out Frankie talk. That we don't get the error when we don't actually use it. But as soon as the compiler actually tries to look up this talk function, you're going to get an error. And that error is that the request for member talk is ambiguous. And so, why is that? Like, what does that mean? Well, the problem here is that character defines this function called talk. And so mage and priest both define an implementation for talk. Remember, a shaman is a mage, and it's also a priest. So when we have two conflicting types here, talk and talk, one on the mage and one on the priest, the compiler doesn't know which version of the function you're actually trying to call. So what we need to do is we actually need to provide our own implementation of the talk method. You could try to define this. So let's say, let's look at some of the approaches that you might take. Let's just say hi. You'll do this, and you're still going to end up with the same error. And the reason why, now, we actually have 3 different potential conflicts. So that didn't actually help. So let's go ahead and mark that as 0. What else might you do? Well, we know that, hey, the character, well, we know that there's 2 different implementations, and it's confused on which implementation to use, so let's go ahead and provide our own implementation. And let's see if that fixes it. So we'll say shaman's rule, we'll build, and voila, our error goes away. And the reason for that now is that when the compiler goes to look up the specific type, it knows that Frankie is a type of shaman, and that shaman actually provides its own implementation. Perfect. So what we really need to do is we really needed to define the functionality so that the compiler is not confused. There are other ways to solve that problem, but they're kind of out of scope for what we want to talk about for today, or what I want to talk about for today. Okay, so I simply just built it, brought up the debugger, and ran it, and we'll see that mage's rule, priest's rule, and shaman's rule. Okay, so really, we've actually implemented all 2/3 of our concepts that we've talked about. Our shaman has multiple inheritance. It derives from both the mage class and the priest class. It's not really doing anything special because we've defined the same function multiple times. So let's go ahead and define a new function for our mage class. Void do damage. Damage. Okay. Let's create a new function. Let's put it underneath talk. Called do heals for priest. Heals. And we're not going to do anything for shaman because shaman derives from mage and it derives from priest. So let's go ahead and try to call each one of these new methods that we've created. So Bob, he's a mage. He can do damage. Henry's a priest. He can do heals. But Frankie can do both. We build. Succeeds. run our output, we'll see mage's rule, damage. Priest's rule, heals. Shaman's rule, damage and heals. Okay, so there's our a little more interesting multiple inheritance class, which derives from both mage, grabs all of the functionality from mage, grabs all the functionality from priests, so it grabs talk and do heals, and it also calls shaman. And then in our shaman class, we re-implement our talk method to remove the ambiguity that deriving from those two classes brings in for us. In our character, what we've done is we've created a abstract class. So let me show you the compiler error. Character, call him, call him Sue. Call her Sue. We build, and this is the error you're going to see. You're going to see cannot declare variable Sue to be of abstract type character. And that's because it's a virtual class, and it has at least one of its functions defined as virtual. I'm sorry, I think I might have told you when we were whiteboarding that all the functions have to be virtual. Only one of them has to be marked as virtual. So if I had another one like this, virtual void shout, for example, like this character still going to be defined as a virtual or as an abstract type. And so even though only one function is actually defined as a pure virtual function. Sorry if I misspoke on that. Let me just clarify that now. Okay, so we rebuild here. We're going to get some linker errors. Let's get rid of that function. Okay. So here we go. We've defined our abstract class. The difference here is that in C++ with an abstract class, we can actually define data members, data fields inside our classes. If you were using a language like C# or Java, you could not do this. You could not say that all of my characters have an int field. You would have to use an abstract class, which would make it extremely hard to do a class like the shaman because you couldn't actually derive from both mage and priest. So that's just a caveat I wanted to point out there. So up here we have our abstract class, or our interface if you really want to call it that. We have a mage class, which is just single inheritance on the character, priest, single inheritance on the character, and shaman, which actually implements our multiple inheritance. Pulls in the functionality for mage and pulls in the functionality for priest. So with that, I'm going to wrap up this video. All right, thanks.